Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems using chain rule for derivatives. So let's start with our first problem on the left side. So given f at x equals x minus 3 square, g at x equals 1 over x, and h at x equals f at g at x, determine prime of h at x. So the first step here is to use this function composition to find h at x. So we are given that h at x is equal to f at g at x. So we should replace g at x with the given equation 1 over x. So the first step is h at x equals f at 1 over x. Now in the next step, we have to find what f at 1 over x is. Since f at x is equal to x minus 3 square, that means then f at 1 over x will be equal to 1 over x minus 3 square. So this is a very important concept we need to understand and memorize. Now we can find the prime of h at x. Now in this case, we have to use chain rule because there is this inner function 1 over x minus 3 and there is this outer function square, the exponential function. So the derivative of this function will, so we start with the derivative of the outer function, which is the exponential function. So we use the power rule. So 2 and then parentheses 1 over x minus 3, and we subtract 1 from 2 in the exponent times the derivative of the inner function, and the inner function here is 1 over x minus 3. So now we have to find the derivative of 1 over x. Now for 1 over x we should move the x into the numerator. So first we can just write it as d over dx for x exponent -1. Now for the second term, since 3 is a constant, the derivative of 3 is 0. Now in the next step, we can simplify this expression. So prime of h at x equals 2 and then 1 over x minus 3 exponent 1, but we don't have to write 1 as an exponent, times. Now for x exponent -1, we can use the power rule to find the derivative. So we will do -1 and then x exponent -1 minus 1. We can ignore 0 because subtraction by 0 doesn't change anything. So in the next step, we can simplify this expression. So prime of h at x equals, so now we do 2 times -1, which is equal to -2 parentheses 1 over x minus 3 times x exponent -2. Now we can move this x term to the denominator to make the exponent positive. So we get prime of h at x equals -2, then 1 over x minus 3 times 1 over x squared. And in the next step, we can multiply -2 by 1 over x squared. So x squared will go in the denominator. So we'll get -2 over x squared parentheses 1 over x minus 3. So this should be the final answer for the derivative of the function h at x. Now we can analyze the second problem. So in this problem, we have to find the slope of the tangent to the curve y equals 3x minus x squared exponent -2 at 2, 1 over 4. So we know that slope of tangent is equal to the derivative of the function to which the tangent is being drawn. So we have to find the derivative of y equals 3x minus x squared exponent negative 2. So slope of the tangent m y prime. So I'm using the prime notation, and now we can use the chain rule to find the derivative of 3x minus x squared exponent negative 2. Now for chain rule, we have to identify the inner function, which is this 3x minus x squared, and the outer function is this exponential function with exponent negative 2. So we'll use power rule for the derivative of the outer function. So we always start with the outer function. So as per the power, move negative 2 to the front, and then inner function minus x squared, and then we subtract 1 from the exponent times the derivative of the inner function. So we have to find the derivative of 3x minus x squared. So the derivative of 3x is just 3, and the derivative of x squared is 2x as per the power rule. So this is the expression for the slope of the tangent. Now since we have to find the slope of the tangent at 2 comma 1 over 4, we can sub in x as 2 in this expression to find the slope of the tangent. So we get m equals, so negative 2, so we'll sub in x as 2, so 3 times 2 minus 2 squared exponent negative 3, and then times 3 minus 2 times 2. Now we have to simplify this expression. So we get negative 2, and in the parentheses, so 3 times 2 is 6, and then 2 squared is 4 exponent negative 3 times, in parentheses, so get 3 minus 2 times 2 is 4. Now we can simplify this expression further. So m equals negative 2. So in the parentheses, we get 2 exponent negative 3 times negative 1. Now we can make the exponent on the 2 positive by moving that 2 to the denominator. So we get equals negative 2 over 2 exponent 3 times negative 1. Now we can multiply negative 2 by negative 1 and we get positive 2, and the denominator is 8. And we can reduce this fraction to 1 over 4. So this is the slope of the tangent to the curve y equals 3x minus x squared exponent negative 2 at point 2 comma 1 over 4. So these are the steps you have to keep in mind to solve these types of problems. So for the first problem, we have to use the concepts of function composition to find function h at x from the given functions f at x and g at x, and then we find the derivative of that function h at x. And for the second problem, we have to use the chain rule to find the derivative of the given function, which represents the slope of the tangent. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.